Thank you very much, Alka, and thank you for the invitation. This country, as a Kiwi, one knows and loves very well. I'm old enough to remember when the Springboks would, or the All Blacks would be in South Africa listening on the radio, and it would take another week before the actual TV clips came to actually watch the game. So that does age me a little. And it also is interesting, I just looked up the current tally between the Springboks and the All Blacks. In the 108 matches, we are ahead by about 20, but judging on the last 8 years or so, I think it's going to be very quick before we are on par with each other. So anyway, the most exciting rugby in the world as far as I'm concerned. A lovely country, and again, wonderful to be here. First time I've ever spoken at a grower meeting, so a privilege. So that all said, I have to write myself out my screen down here. I'm going to move from a modelling world to a world of the life that we live with apples. And one day, Peter, the dream would be to have post-harvest technology of browning, a thing of the past. But unfortunately, I think you and your children and your grandchildren will have plenty of work to do in the future. I don't think we'll ever crack these browning problems completely. So I'm going to talk three things I want to focus on today. It's sort of really talk about DCA and 1MCP in the USA, just sort of giving you an overview of what's going on there in terms of our industry, a very rapidly changing landscape, and then a quick summary. So, I think you're familiar with a range of DCA systems. The Harvest Watch system, you need no introduction to, very, very dominant here, I think, in South Africa. But you have the RQ system. This is, there are room-type RQ systems. There are, that second picture from the right, the safe part system, where a little RQ system is put in the middle of the fruit bins. We have ethanol-based systems, whether there's ethanol in the air or in the fruit. And then there's a fourth system that has just been released in the last 2 or 3 years, which is based on carbon dioxide production. So it's an ongoing, growing area, and one that is incredibly of importance to many of us. So I think South Africa, I'm sorry, I should have looked it up. When did 1MCP get registered in South Africa? About 2000, about same as Europe, I'm guessing? Pardon? 2001. Or 2000, so you're similar to the US, okay. So in the US, we had both 1MCP and DCA were released around the same time. Whereas in Europe, it wasn't available till about 2005. The registration processes were a lot longer. What happened here is the really positive market reaction in the US to 1MCP really gave 1MCP a huge amount of leverage, that long-term advantage of 1MCP through the entire marketing chain. And then the ease of applying 1MCP. In New York, we have a lot of modern stores, but we have a lot of stores that are not that super airtight along the lines that you need for DCA. And as part of my introduction, I should have spent less time talking about rugby. I just mentioned, some of you won't know what the heck New York actually has an apple industry. Just to mention, it's about the same size as South Africa. We have 3 major growing regions. We have the Hudson Valley, which is down by New York City, which sadly, growers are making more money growing houses than they are apples. We have the North Country, which is near the Canadian border, and then we have a huge apple industry along Lake Ontario. So 3 very distinct climatic zones. Now that I've added on my bit that I forgot. Third, diphenyllamine for us is still available, all right? So that makes a huge difference in the way that our industry is able to operate. And we have, in fact, lost most of our export trade. Not that it was all that significant, but we've lost our export trade to Europe for the most part. The organic fruit production outside of Washington is small, so DCA was not a driving force for that. And at least in the Northeast, and we had back then, and we'll move on, I'll explain that in a little, a number of traditional varieties, Macintosh, Empire, soft apples, and we found that the residual effect, what happened when you took the fruit out of storage, was poor. And I'll illustrate that by an apple called Macintosh, which everyone in this room should be thankful you don't grow. It's a little similar along the lines of Cox's pippin, which you used to grow, I think, many, many years ago. But the take-home message from this figure here, basically there's 4 panels here, 4 months plus 1 day, 4 months plus 7 days at room temperature, 8 months plus 1 day, 8 months plus 7 days. The take-home message here, if you look at the dark blue, 4 months, 1 day compared to 4 months, 7 days, and similarly for 8, 1 and 7, is once that fruit comes out of CA and DCA, you have a rapid loss of texture, a rapid loss of firmness, approximately 25 to 29%. In other words, DCA did a nice job in storage, but once you took that fruit out, unless you had treated that fruit with 1 MCP, you had a rapid loss of condition. So basically, we kind of generally walked away from that. However, it is a new landscape on two reasons. Mainly, well, number one is cultivar physiology. The range of new cultivars, I don't think is happening here to the same extent in South Africa as it is in North America, but the effect of Honeycrisp as an apple has revolutionized the apple industry, and we have so many clump varieties that you can't turn without finding a new one. So it's really, in a way, it's a little bit out of control, and the market is going to calibrate, I guess, at some point. The second reason that we've had a lot of change is the storage disorders. And so I will show you some more browning photos in a moment. So here's our new world, Honeycrisp and its progeny. So Honeycrisp has been used in breeding programs for Wild Twist, Evercrisp, Snapdragon. And then there's these new varieties, well, Gala is not quite so Gala, sorry, I'm in South Africa. Gala is not so new. Worked on that for many years when I was in New Zealand. Pink Lady, which I know is an important apple for you. We are just really starting to have Pink Lady come on in large volumes in New York, and other club varieties such as Envy. So this illustrates why that whole photo or that picture that I showed you comparing Macintosh with Honeycrisp becomes irrelevant. It doesn't matter whether you use 1 MCP, doesn't matter whether you use CA versus DCA, the texture of that fruit is going to stay the same. That isn't quite the same necessarily for acidity, because we know that plus 1 MCP, that Honeycrisp apple will be more acidic, will have better internal eating quality. But the bottom line is you don't have that softening flesh in the same way. Fuji is similar. There are no little letters to indicate differences there, but Fuji is another apple where relatively little effect of, we're not concerned about post-harvest storage in the same way that we were with Macintosh. But with Golden Delicious, still an important apple for us. This is part of an organic apple trial. You can see there a similar pattern as I showed you with Macintosh, where even though the fruit that comes out of DCA is firmer than the fruit that comes out of controlled atmosphere storage, without 1 MCP, you do get considerable loss of texture after it comes out of storage if you have not treated that fruit with 1 MCP. We've got a very, very good sensory lab at Cornell that just illustrates on a liking of 1 to 9. This overall liking just pulled out some of this data comparing Honeycrisp, Fuji, Golden Delicious, and Jolly Gold. If you look at Honeycrisp and Fuji, the ratings are the same whether you have CA plus 1 MCP or DCA. But in the case of Golden Delicious and Jolly Gold, which are varieties that soften after they come out of storage, you'll see that basically you have to have CA plus 1 MCP to give you the equivalent of our DCA in terms of overall quality. So moving to storage disorders, the big change for us in terms of industry interest in dynamic controlled atmosphere was as a result of Gala. I'm going to talk about that this afternoon a little bit more in the context of plant growth regulators. But I used to not want to work with Gala apples because they never had problems. I never saw a problem with Gala in New Zealand when I was working for many, many years. However, what is happening with the increased volumes of Gala in North America, we are starting to see a large range of these physiological disorders. One of them is a stem end flesh browning, where you see the browning in the stem end of the apple before you see it anywhere else. And traditionally, our focus was always on bitter pit, and we would always be chopping the apple from the calyx end. And we realize now that we need to be cutting apples from the stem end as well, because the people that started yelling about this browning problem were the processors, the fresh cut slice processing in people. And then, of course, flesh browning and core browning. As I say, I'm going to talk about this afternoon because this involves work with our PGRs, specifically Retain in this experiment. But the take-home message is you compare what used to be very recently our traditional storage recommendation for Gala, 2% oxygen, 1% CO2 at 0.5 Celsius. You can just see on the bars on the left-hand side, the control and the control plus 1 MCP, very high levels of internal browning. On the right-hand side, 0.5% oxygen at 3 degrees Celsius, so both lower oxygen and warmer storage temperatures, you pretty much eliminate the flesh browning. Again, I'll talk about that this afternoon. So the question is, so all apples will respond to low oxygen, right? And the answer is yes, no, and maybe. That's the world that we live in with these new varieties. Varieties that are not affected by one, we have three types, if you like. Varieties that are not affected by 1 MCP, but browning disorders are decreased by DCA or low oxygen. Gala was the example that I just showed you. Now, again, we'll talk about that again this afternoon. We have varieties for which browning is enhanced by 1 MCP. And this is actually sort of a relatively new phenomena that we're finding more of these newer varieties are actually developing more flesh browning in response to 1 MCP. All our early work was done with very traditional varieties, and we never saw issues with 1 MCP causing more browning. But that's our world. And then I'm going to show you an apple that you don't have here. Oh, you may actually have planted here, but small scale Snapdragon under some experimental permits. And then the third group are varieties with no effect of 1 MCP or DCA on browning, but only limited research. And here I want to, are they going to hear about the Crips Pink work at Stellenbosch today? Oh, they know about it. All right, good. So you know, we were at a conference a couple of weeks ago, and there was some really interesting work on Pink Lady or Crips Pink that was presented there. And I don't have much to offer additional to that. But here's Snapdragon. This is a New York one. This is another one of these club varieties with Honeycrisp parentage. And the take-home message here, we look first at the stem end flesh browning on the left-hand side. The blue is harvest 1, the orange is harvest 2, so that's a 1 week difference in harvest. Controlled atmosphere storage is the first group. Or maybe I should use this here, right? Here's our controlled atmosphere. Here's our controlled atmosphere with 1 MCP, and you can see a huge stimulation of internal browning in in controlled atmosphere stored fruit with 1 MCP, more at harvest 2 than at harvest 1. DCA, similar to CA, but DCA plus 1 MCP, a similar pattern that we see for CA. Internal CO2 injury, which we control with diphenylamine, which you don't have the pleasure of that chemical anymore, but that's a non-event, but you can see not all that much difference, nothing that we can control with our carbon dioxide manipulation. On the right-hand side, we have core browning. Here we see, again, that certain harvest dates, the blue being harvest 1 MCP stimulates, so does DCA. So really a complex picture that we can probably spend more time than you want to talking about this particular variety. But we do know that there's an influence of maturity. Most of our industry, as I will explain this afternoon, is using PGRs very, very intensively. But here's a simple bit of data with New York 1 with retain. The untreated CA, 42%, the retain, 8%. DCA stimulated the flesh browning, but that stimulation was still stimulated with DCA plus retain, but the levels with retain are lower. The take-home message is, because we're in the middle of a lot of work on New York 1, I have to because the New York apple is keeping us busy, but it just shows you the complexity of what is happening with a lot of these new varieties as we try to manage the balance between DCA, CA, and pre-harvest plant growth regulators and post-harvest plant regulators. Now, Crips Pink and Pink Lady, as we just talked about, is actually a very unusual apple. There's been a lot of international work, and it really drives home that the effects or the storage ability of Pink Lady and its susceptibility to different storage disorders is affected not just by country, but region within a country, and susceptibility to CO2 injuries, temperature chilling injuries is very, very complex. So we've just started working with Pink Lady for the first time. So we are well behind you in terms of understanding this apple. But just to illustrate maybe one thing that is not so surprising, this is Pink Lady from 2 separate orchards. This is superficial scald, and the controlled atmosphere storage without 1 MCP, obviously high levels of scald, especially in orchard 2. So, but basically under our hands, DCA will control scald, which again is what you would expect. And again, something that I forgot to mention, of course, in terms of DCA work, South Africa is really leading the way in terms of what we call short-term DCA. Thinking about your industry, like the New Zealand industry being very focused on export, and that's very interesting in and of itself. So we look at Pink Lady flesh browning, on the other hand, we see for us at this stage the most dramatic effect, much more important than whether it's controlled atmosphere or DCA plus or minus MCP. The real effect is actually temperature. Storage temperature is the most important denominator, but that is not necessarily the same in every country. And I see I have 1 minute left, and I think I'm going to bring it home. So, new varieties and reflections. Results for the DCA are complicated further by different countries with different step cooling procedures. We in New York, nobody uses stepwise cooling. I was in a meeting in Wenatchee with a New Zealand group talking about envy, and apparently they do all their stepwise cooling. I'm not quite sure what the situation is here. I think you do stepwise cooling here as well. We just slam them in. If we do stepwise cooling, it's because our refrigeration capacity is not really all that good, but it's not done deliberately. Slower cooling requirements can result in loss of fruit condition, But there's still a tremendous amount of work for generations to come, maybe, for ongoing research and what I call co-development with industry, because we're way past the days where we used to have all the answers. So I think my time is up. Should I go through the summary very quickly or just part? All right, very quick. Summary number 1, increasing the use of DCA for conventionally growing fruit is only making sense where it makes an economic difference. The limits for us still remain room quality issues, relative benefits compared to the one MCP, control of certain dose disorders. For us, losing DPA in North America, which may happen one day, will change our world. And then what am I saying? The take-home message in terms of this group is every cultivar is like a new fruit type. So when you have an administrator saying, you people have studied apples for 100 years, haven't you got some answers yet? You have to remind them that this is our world. So I'm going to just move on and finish with that. And I think the questions are after, right? Thank you very much.